In addition, they used operational taxonomic profiles to train a naive Bayes model on a sample from the data. So they essentially built MOs for each group and then used those to train the naive Bayesian model. An additional difference is that they predicted a set of 10 groups that were potentially responsible instead of predicting a single group for responsibility. That differs significantly, and it's one of the reasons that we've conducted the study that we did. Their model yielded good results, about 81% accuracy, but there were several significant issues with it. First of all is an untenable assumption, which is the independence of predictors. Naive Bayes has an assumption of independence of all independent variables, and there is significant collinearity within the data set that they used. As you can see, the variance inflation factor was well over 5, which is usually the rule of thumb, and the median was also over, 2, which is also over. The model performed well despite this, again, 81%, even showing a fair robustness to artificially introduced error. They did introduce some to show that their model was robust and did quite well. However, they also judged success by a much different criteria than anybody had previously. What they did is they took their groups of 10, and if the right group was predicted into that set, it was counted as a successful prediction. And so it's while they predicted out of a set of 2,500 groups, so 10 is still pretty good to get one out of. It's still much less than we would like to see in terms of accurate prediction of a single group that's responsible. So that brings us to the data and sort of what ISVG is, who's been providing the data for most of these studies so far. We're called the Institute for the Study of Violent Groups, and what we've done is we've built a database. It's a large SQL Server 2005 database of terrorist incidents, individuals, and groups. It was originally developed by Dr. Richard Ward out of a project that he's been going through since the 1970s, which originally consisted of cutting out newspaper articles, sticking them into pieces of paper, and filing them in appropriate categories. In 2003, the Bureau of Justice Assistance in the Department of Justice funded ISVG and Dr. Ward to try their hand at creating a database to see if it would work, with the basic idea, very basic idea, behind it being, can you collect surface level variables from news articles all over the world and use it to solve the whodunit question? Everything in it is from open sources. There's no secret, there's no data above general access level, so all of the data is totally open source. We are not, I don't think yet, although we're probably up there, we're not yet the largest in the world in terms of the amount of data. We are the largest collection operation currently that we know about. We have over 30 collectors with 10 different languages represented. And there are over 1,500 variables on multiple levels of analysis. As I said, we collect incident information, we collect group information, and we collect individual information. And as far as I know, we are the only currently operating open source database that collects information on individuals. So we utilized ISVG's open source data, particularly on the Philippines. And we did this for a couple of reasons. Primarily, because it provides an interesting case with multiple groups, but there's not, while there are several more than we ended up classifying them as, it wasn't an abundance. There's certain conflicts, Pakistan, India, that are incredibly difficult in terms of number of categories to predict into. So we were trying to do it with something that was a little more manageable at first to prove the concept. Secondarily, there was a high percentage of known attacks. About 70% of the attacks were known, actually a little bit less than that, but compared to a lot of other regions, it's much higher and better, and so it makes it easier for us to assess the accuracy of our classifications. In addition, we wanted to do it on a conflict that was active. It doesn't do a lot of good to classify conflicts that have ended a number of years ago, so we wanted to make sure that whatever we found was useful. So moving into the data that we used itself, we used the ISVG data of all violent attacks in the Philippines with a known perpetrator, about 941 in total. This is out of a total of about 1,400 incidents. The dates that we covered were January 1st, 2004 through June 30th, 2008. And we ended up utilizing 4 groups. First, there's the Abu Saif group. They are a supposedly Islamist organization that has largely become more criminal over recent times. They primarily operate as a kidnap for ransom gang. There's the Moro Islamic Liberation Front, or MILF. They are a group that is out there to try and get an independent Moro state within the Philippines. And then there's the New People's Army, which is best classified as a communist insurgent terrorist organization. The other category is made up of a number of groups that have also committed acts in the Philippines, but by far they're the smallest group in the data set, so each group was responsible for 1 or 2 acts only. We have 87 dichotomous predictor characteristics. We include all kinds of different characteristics in terms of the classification. Incident level variables such as geography, weapon type, month, day, tactic, several others. We can go into more detail if there are questions. I don't want to start with this one over here. This is just a brief overview of some of our data, and the reason I'm going to show it this way is because it's a little easy to understand why we suspected some of the things we found were coming. And it was a good way for sort of us to assess how sort of realistic the model that we ended up with was. And so here what this is this is a tile chart which is showing group activity by state. Each group here is represented by a different color. This is not yet grouped to the other groups, so every color represents a different group. And here what we can see is, by and large, attacks in the Philippines, especially by state, are relatively homogeneous. You can see that, for instance, in many of these down here in this corner, basically have no attacks by any other group except for the NPA. And the NPA is by far our largest group, responsible for about 70%, a little over, of the attacks. And then you can see, however, that there are other places where we have multiple groups engaged. And we figured that these would probably be the least effective predictors. What we found later, as Dr. Miller will go into, is that we were half right in terms of our suspicions regarding the geography here. One of the other things that we looked at was tactics. Here we can see and target types, which is how this bar chart is done here. Armed assaults are by far the most prevalent type of violent attack in this data set, and of those, the vast majority are against individual targets. Other options are buildings, non-building infrastructure, which is things like light poles, and more geared towards vandalism than actual attacks against people or other targets, vehicles, and one other that's escaping me at the moment. The second most prevalent type of attack, actually there's 2 of them, is arson and hostage-taking and kidnapping. Both of these are relatively frequently used. If you'll notice, hostage-taking and kidnapping has no values for the target type. That's because, by definition, the way ISVG codes, hostage-taking and kidnappings are always against individuals. It's not frequently that somebody takes a car hostage. So we stuck with that. When we're examining casualties over time, what we notice is that it's also fairly homogeneous. There aren't a lot of peaks and valleys in terms of what's going on. It's been a relatively consistent in terms of deaths over the entire course of the data set. Interestingly, we do have 2 larger attacks at the very beginning, which we thought might be relevant, but ended up not really showing up in terms of variable importance, as you'll see.